Hello to all our listeners. My name is Sadia Anwar. I am acquisition editor, River Publishers. Today we are stepping into the groundbreaking field of stem cell research. We are joined by Dr. Pranela Rameshwar, an esteemed professor at Rutgers University and the editor of the insightful book Stepwise Culture of Human Adult Stem Cells. Thank you, Professor Pranela, for joining us for this podcast. Firstly, I would kindly request you to introduce yourself in a few lines.
Yeah, I'm Pranela Rameshwar. I'm a professor at Rutgers University, within their Rutgers Health schools, specifically at one of the two medical schools, New Jersey Medical School. And my research involves stem cell and breast cancer, and I also teach four STEM graduate courses.
Thank you, Professor Pranela. Following that, I would like to ask, as we delve into this discussion more, could you first provide us with an in-depth overview of stepwise culture of human adult stem cells and enlighten us on the unique contributions this book makes to the evolving field of stem cells research?
Well, after doing research for so long, and one of the things I realize is I have a method book in the lab. And so when new people come into the lab, they can follow that stepwise procedures. So I feel it was time for me to put all the stem cell culture together, which was adult stem cell, together with the needed methods and put it in one volume. And so this will help because not every lab works in stem cell and they're not familiar with stem cell culture. And if you look at the publications, you have limited words that you can read the method. So I thought it would be easier if someone can use this book and then follow stepwise in a very understandable way. So it could be a new postdoc working in it. It could be the PI, him or herself, working in it, and they can follow the method. But more importantly, there is no standardization actually of these methods. And I think this has contributed to a lot of confusion in the field of stem cell. For example, my lab in the United States might be culturing the cells very differently from another lab in another state or in another continent. And if you look at people's publication, they keep modifying the method, but it's not very obvious in the method section. And so I thought maybe with multiple publications that I have from my lab, I should use those methods and just describe it in one volume.
Diving deeper, how do the methodologies detailed in your book stand out from existing practices, and what significant impact do they have on the way current stem cell research is conducted?
Well, it goes back to what I said before. If you're a lab and you work with one stem cell, say hematopoietic stem cell, and you want to address a question because those cells exist with other stem cells, you may want to address a question, say, with mesenchymal stem cells to see how they interact in the bone marrow. Then you really don't know how to culture one or the other. The other thing, there's not all stem cells are equal. For example, recently someone asked me, can you keep your hematopoietic stem cell in culture and see if they survive for long term? But it's known that you cannot keep those cells in culture. The moment you put them in culture, they start differentiating. So I figured in this book, people will really get a sense of the differences and know that one cannot be extrapolated to another. And I think that's what makes it so different because I don't know of any other book that has all the stem cell method culture in one volume. I could be wrong, but I don't think so.
As we transition to a more focused look at the contents of your book, the book covers an impressive range of stem cell types. Could you point out the chapters that you feel are particularly groundbreaking and why they are transformative in the context of stem cell science?
Well, they're all equally important. I think what's transformative is the accompanied method. For example, if you're culturing one stem cell, then you may need other method to do flow cytometry to characterize those methods. And the book describe what is needed and what may be accessory method. And then it lead you to that method to describe. So you have the basic stem cell, but you have the method in the other technique that you need to characterize. And I think that's what's so unique and transformative in this specific method book. The other thing I really had in mind when I write this book to make it transformative, you have these labs and they're taking in new trainees, right? Who is there to teach these students? Everyone is busy. And if they want to do stem cell, that naive student could pick up this book and start perfecting the method. So I think this method is not just good for established scientists or PIs, it's also good for students, really good for students and postdoc and or a new lab coming into the field.
The book also brings into contrast the methodologies surrounding adult versus fetal stem cells. In light of this, could you expand on the major differences in their isolation and growth processes and what makes these differences more significant?
Well, I did include two fetal stem cells in the book, and that's from the umbilical cord and also from placenta stem cell. And I think that's what makes the book actually unique, because if you're working with bone marrows, mesenchymal stem cells, for example, as a major area of research in your career, which I did for a long time, and then I started to work with placenta stem cells, and I realized you cannot extrapolate one from the other. One is coming from bone marrow aspirate or maybe from adipose tissue. And you see that there's a difference with the starting material and what has to be done, and the way you process it could actually affect the outcome. And so that when you look at cord at the beginning, in the early days of the field, you think you can culture it from the blood, but it's not in the blood, it's in the cord. And the way you cut it, the pieces to get it, it's very different than the bone marrow or from adipose tissue. And when you go to the placenta, they're different membrane. And so you can't just chop the placenta up. It's like, or you may be mixing the stem cell from the different membrane. And so that's what makes it so different.
If we see the impact on scientific community and moving on to the broader implication of your work, establishing standard method is a concern stone in scientific advancements. How does your book contribute to this essential aspect in the area of stem cell culture? And why do you believe this standardization is pivotal for the future of scientific research?
Yeah, thank you for this question. Because when I started this book, I was really frustrated, right? Because we will have journal club and you will see the outcome of the stem cell very different from one part of the world or one lab to the other. And when you delve deep into the method, you realize there was no standardization. And so, although this book is not meant to be a standardization method, you hope that it will be a guide to a standard. So, if, for example, you're doing a research in one lab, say in Brazil, and you have an outcome, and you look at the outcome and it's different from, say, a lab in Europe, this book could be a good guide. Say, aha, this is what I should look for. I cannot presume I had stem cell. I should do some characterization. And maybe I should look at how I'm culturing the method.
Following the same question and looking towards the future of medicine and research, in what ways do you envision this book playing a critical role in shaping translational studies and propelling the field of regenerative medicine forward?
So, I'm now transitioning from academia into a biotech. And you realize in pharmaceutical and biotech, time is the limit, right? And if you want to work with stem cells, it will take months and months if you're a naive lab to start developing method. And I think this book will be a guidance to shorten that time. So in a way, could speed up translational medicine. It would speed up anything going to the market. The other thing too that it's a good book for students, and it will take away a lot of frustration because based on my experience in mentoring students for a long time, students get frustrated when they're repeating something over and over. And so you need these young people to stay in science so you can improve healthcare. Because if you don't have innovation, you're not going to have improved healthcare. Yeah, so when I had something so broad in mind when I was decided to prepare this book.
We see the broader influence and inspiration. What inspired you and the other authors to consolidate these cutting edge methods into a comprehensive guide, and what do you hope to achieve with this compilation?
Well, as we started it, it became a cause where the author said, because they themselves were working with these specific stem cells, and they themselves saw the frustration when they started because we had to develop all the method together. Then we found that, there was more modification that we should do to make it efficient. So it became a cause. It's like we know now, and let's help other labs and other system like biotech and thing. And they see if it delayed their process of doing their research, but if they can have one source where they can go, because you can jump from one stem cell to the other. And if you're growing the stem cell, you just don't take it from a lab and do an experiment. If you don't have standard characterization of the method, so you can compare with what's known in the field, then your experiment will be a waste of time. And you could spend 2 years and the outcome just doesn't pan out.
Considering the comprehensive scope of this book, what do you see as the primary beneficiaries of its contents, and how can it serve as a valuable resource for their research or academic pursuits?
Yeah, so I think I've been kind of alluding to this question throughout because it's a book that is there, one source, several types of stem cell culture, the accessory method needed to characterize them. And then now you have a student coming in to start a PhD. That could shorten that student time. You have a postdoc who's now trying to transition in the independent career. That could really help that person to start, rather than wasting time developing method, start addressing a hypothesis in a very short time. Then you have pharmaceutical and bio, so those are students. You have now labs who might be molecular biology lab and realize that they have to address their question with a stem cell, but another stem cell lab. So where do they go? Maybe you can go to another university or try to walk around a big university like Rutgers and find a lab that may not be efficient. So that could help that lab. And then you have the biotech, rather they have limited resource and they're trying to get a drug to the market, or you may have a pharmaceutical. And so rather than trying to develop it and spend months and wasting resources, and also for people who are teaching their stem cell classes with accompanying labs. And so this could also be important in the undergraduate level, actually.
To wrap up our discussion, I would kindly ask Professor Vanilla to share your thoughts, and also how do you anticipate the principles and methods outlined in this book influencing the trajectory of future research in stem cell therapy and clinical applications?
Yeah, that's what I was saying, that it isn't the research, maybe standardize the research. So people would use the method and they realize that you can't just culture these cells. So for example, something simple in mesenchymal stem cells, you can't bring them to confluence. So this book will tell you. And so some labs have been doing it to confluence and some are doing it right. And so the research is mixed. And when it's mixed, it's really slowing down clinical application. And these cells, some of these cells are now in clinical trial to inject into human. And so you hope that people will start taking this book now, see what they're doing, and maybe they're doing things right, or maybe said, aha, maybe I should try something. And not only that, the people who are working in the group would realize, you know what, we don't just take these cells from the incubator into an experiment. How do we know they're actually stem cell? And all of that will shorten the time, the waste of time actually in the field. And I'm speaking from experience because that has happened to us.
Thank you, Professor Vanilla, for joining us for this podcast. It's been wonderful having you share your expertise with us, especially about your book. We extend our heartfelt thanks for joining us today.
Thank you.